Last episode ended on a single line item, the one where a human checks whether the machine's work is actually right, and I told you it had just become the most expensive thing in software. Here is why. In 1969, at a NATO conference in Rome, a room full of people were trying to work out why software projects kept failing. Edsger Dijkstra said one sentence that outlived every other thing said in that room. Testing shows the presence, not the absence of bugs. It sounds like a complaint about testing. It is not. It is a statement about the limits of knowing. You can run 1,000 tests and pass every one, and what you have established is something about 1,000 cases out of a number that has no end. Confidence is not proof, and that is not a flaw in your tests, it is the shape of the thing. Which is problem number 4 of our 7, and it is the one I would defend hardest. Building something and knowing it works are two different activities, and the second one is never free. Ground truth is reality. The program either meets the need or it does not, and reality does not negotiate. Now watch the servants, because this timeline behaves differently from every other one in this series. In the 1950s, desk checking, reading your own program on paper because machine time was scarcer than thought. In 1976, Michael Fagan at IBM turned review into a formal ceremony with roles, checklists, and defect counts. Then unit testing frameworks, verification industrialized at the smallest grain, then test-driven development, then code review as a habit once pull requests made it cheap, then continuous integration, verification made ambient, every change, every time. Then observability, testing in production made respectable. And now, eval harnesses and machine review, the fastest growing practice in the industry. Here is what is strange about that list. In every other episode the timeline replaced itself, cost models gave way to error budgets, phase gates gave way to iteration. This one does not. Ceremonies changed, Fagan's meeting is gone, but no layer was ever removed. We still debug, and test, and review, and monitor, all of it, all at once. This is the only pillar that purely accumulates, and things accumulate when nothing has solved them. So what does AI do to it? The most violent thing ever done to it, and it comes from one side only. Generation got cheap. Not cheaper, cheap. Verification did not move. Reading 100 lines to decide whether they are correct costs what it always cost, and knowing a system well enough to say what would break costs the same. The machine got faster at producing work, and nobody got faster at checking it. Call it the verification asymmetry. It is the defining economic fact of this era, and it moves the bottleneck. The scarce person is no longer the one who can produce, it is the one who can tell. The obvious escape is to have the machine check the machine, which is a real practice and genuinely helps. It does not close the loop. It inherits the same blind spots, and it cannot be the ground truth. Somewhere the chain has to touch reality, a real user, a real incident, a real number that either moves or does not, and a human who decided that was the right number to watch. Which points at the skill, the one that was always quietly undervalued. Be able to tell. Read code faster than you write it, say why something is correct rather than that it looks correct, write the test that would fail if the thing were wrong, which is much harder than writing one that passes. If you are asking which of the 7 to invest in first, it is this one. Nothing here has ever been retired, and the price is rising fastest. But there is a trap in the word works. Verification tells you the thing works today, against today's world, and software does not live in today. So suppose it does work. Will it still work next year? Next episode, software rots. Everything that works starts decaying the moment you stop touching it.